Hello, dear students. This is م.هۆگر, a chemistry teacher at Zhyar High School for both Kurdish and English system. We decided to record the video for both courses, inshallah, if we have enough time, of course. Well, before starting anything, I want to say some important things that are necessary for you as a student of grade 12. And those information that I want to mention, well, one of the best points for you before starting anything, you have to make a perfect revision for those information that you've learned at grade 11. Well, maybe you ask me, okay, mister, what information is necessary for me to make a revision? Well, the first point, you have to know how to write a chemical formula, chemical symbol for ionic compounds, and then how to include this compound into a chemical reaction when they face each other, okay? So please, hopefully you remember and still you have those informations, as I say, that you've learned at grade 11. So before watching this video, please just spend 20 minutes or half an hour for make a revision of basic informations about what are the ionic compounds, what are the molecular compounds, and how to write their formula. And then, look, this is very important, how to write a double displacement reaction, a single displacement reaction, and acid-base reaction called neutralization. And most importantly, how to write a combustion reaction. Actually, I'm going to mention each of them when we reach at its suitable time, but you know, for you, if you have a prior information, it will be the best starting point. Well, let's start by chapter 1, section 1, okay? Well, actually, I prepared my pamphlet, which is here, okay? But I don't want to explain on my pamphlet directly because of I want to mention some other informations, okay? Look. Sorry, because of I'm not still quite familiar to using this smart board, okay? Well, this is chapter 1. Chapter 1 contains two sections. Chapter 1 contains two sections. Section 1, ions in their aqueous solutions. We're going to deal with the number of ions in their aqueous solution when we put ionic compound. And section 2 is about colligative properties. Well, ions in their aqueous solution and colligative properties, these are two sections. We're going to study them in the chapter. But I don't want to start by section 1 directly because of I want to mention some basic information. So please be careful and write down everything that I'm going to mention. And you always start in a store section of your brain, okay? Well, let's start by those basic informations. I want to classify a compound. Well, first of all, what is compound? Compound, we know that is a chemical material contains two or more types of atoms. Well, compounds generally classified into two major classes, which are ionic. Well, I prefer to write ionic in this side, okay? Where's endo? Okay, it's very good. Well, compounds are classified into molecular compounds. Molecular compounds. Well, molecular and ionic. That's good. Okay? So from now on, you have to know that. Tell me what class do you have? What class do you have for compounds? Okay, mister, we have ionic and we have molecular compounds. What are the classes of compounds? Ionic and molecular. Well, For ionic, we have ionic compounds, and they become two. We have further classifications for the ionic compounds, which are salts. Salts and strong base. Strong base. Okay, strong base. Well, compounds are classified into ionic and molecular. But for the ionic compounds, we have, look, for ionic compounds, we have strong base and the salts. Okay? So, be sure that you're gonna be best recognizers for salts, strong bases, and molecular compounds. But you have to be a patient. Don't be in a hurry, please. I'm going to tell you everything. I'll teach you everything. Just be a patient, okay? Because of, you know, it takes a time in order to be familiar with this subject. I'm in chemistry. It takes a time. So please, just be a patient. Well, ionic compounds, they become strong base and salt. Well, here I want to mention some examples as a strong base, such as group 1 and group 2, not all of them group 2, but some of them, plus OH. Okay, well, such as NaOH. NaOH is strong base called sodium hydroxide. I'm using sodium hydroxide as a strong base of group 1 elements, and calcium hydroxide, CaOH by 2, which is also a strong base. For the salts, we know that salts are compounds that contains ionic assembly between cation and anion. Look, for the salt, we have cation and anion, positively charged ion and negatively charged ion. They assemble through ionic bond. They connected, okay? They connected through ionic bond. Look, such as NaCl, your beloved salt, such as most of my students, when I ask them, okay, tell me one example as a salt. Immediately, I knew that they will say NaCl. Okay, and for example, Al2SO4 by 3. Aluminum sulfate. Okay, mister, but how we can make a differentiate between salt and strong base? As I told you, don't be in a hurry. Just be a patient. I'll teach you one by one, okay? But for you, for now, you have to know that ionic compounds become salt and strong base. Okay, that's all. You will know what are the strong bases and what are the salts. Well, and now molecular compounds. Actually, we have to deal with it in detail. Well, for molecular compounds, okay, molecular compounds. Good. Well, molecular compounds, we have further classification also. Molecular compounds, they become polar and non-polar. Non-polar and polar. Okay, we have polar and we have non-polar. For molecular compounds, we have polar and we have non-polar. Okay, it's so simple. Well, non-polar molecular compounds generally contains, most of them contains carbon plus hydrogen, and we have some exceptions also, such as CH4, methane gas, and CCl4 chloroform or carbon tetrachloride, benzene, cis H6 benzene. This is not a commercial benzene that we're using as a fuel of our car. This is benzene compound, is totally different from that benzene from the petrol stations. Okay, that is gasoline. Well, and for example, lipid, oil, okay, etc. These are nonpolar. These are nonpolar molecular compounds. Well, but what means by nonpolarity? And what mean by polarity? Okay. Well, the best point is that for me as a quick point, quick answer, quick response, you have to say, okay, polars, they can dissolve and be miscible with water, but nonpolar, they don't have this ability. Okay, polar will be dissolved and miscible with water, will be dissolved in water and miscible with water, but nonpolar, they don't have that ability. Okay, but the most scientific answer for the polarity is that polarity, it means positive pole and negative pole, okay, as a result of inequality of electron distribution between the atoms, negatively and positively charged. So this is a polarity, but you know, you're not obligated, and this is not mandatory for you to know this deep information. But you know, for you, this is a good point. Nonpolar cannot be miscible with water and can dissolve in water, cannot dissolve in water. But polar, yeah. Well, for polar, we have two types, again, for the classification, such as electrolyte and non-electrolyte. Electrolyte and non-electrolyte. My God, such a nice handwriting. Okay, so okay, just I want to mention something. Please don't mention my grammatic mistakes, because of you know that I'm only a chemistry teacher. I'm not an English teacher, so it's possible for me to make a grammatic mistakes. Well, non-electrolytes and electrolyte. Oh, sorry, both are non-electrolyte. Okay, for polar, well, okay, for polar, we have non-electrolyte and electrolyte. Okay. Well, molecular compounds, we have further classification, non-polar and polar. Okay? Polar compounds, they become non-electrolyte and electrolyte. Non-electrolyte and electrolyte. Okay. For non-electrolyte, first of all, polar molecular non-electrolyte. That means they will dissolve in water, but they are non-electrolyte. Polar electrolyte, that means they will dissolve. They can dissolve in water, but they are electrolyte. Now we have another problem. What means by non-electrolyte and electrolyte? This is very, very, very important. So, well, let me give you some idea about the word of electrolyte and the words of electrolyte and non-electrolytes. Okay. Non-electrolytes, okay, we are using these expressions for those compounds when they dissolve in water, but the aqueous solution cannot conduct electric current, electricity. Okay, for example, well, look at this. Okay, now that's the direction of the subject changed to the difference between electrolyte and non-electrolyte. Electrolyte, that non-electrolyte, that means when they dissolve in water, dissolve in water, okay, they will produce, of course, aqueous solution. This is aqueous solution of non-electrolyte. And now if we apply a system to check its conductance ability, cannot conduct electric current. Okay? Well, non-electrolyte compounds, when they dissolve in water, they produce an aqueous solution that doesn't have the ability to conduct electricity according to Arena's experiment. Well, non-electrolyte compounds, that means when they dissolve in water, they will produce aqueous solution that cannot conduct electricity. That was a non-electrolytic property. Well, why they can't conduct electric current? Wait for the answer. Well, as examples of non-electrolyte that are polar, such as sugars and alcohols. Sugars such as C6H12O6, alcohol CH3OH, or C2H5OH. Look, I mentioned each point quickly, but you know, in my pamphlet I have mentioned those informations in more detail. But for now, for you, just the idea. The idea is important. Okay. Well, but still, the answer of that question is remain. Why we have this problem? Cannot conduct electricity. Wait. Electrolyte, when they dissolve in water, dissolve in H2O, okay, they will produce aqueous solution, look, that can conduct electric current. This is the exact difference between non-electrolyte and electrolyte. Aqueous solution of non-electrolyte cannot conduct electric current, but for the electrolyte, yeah, they can conduct electric current. Okay? Why we have this difference? Here we don't have any mobile ions in the solution. There is no ions. Okay? We have no ions in the aqueous solution of non-electrolyte. That's why there is nothing to carry electric current from a point to other point. So all the solution become non-conductor. But here we have ions. Okay, so there. Well, let me write in another way. Look, we have ions. We have ions in the aqueous solution of electrolyte. Okay, so this is the exact difference between electrolyte and non-electrolyte. Non-electrolyte is a compound that can dissolve in water, but its aqueous solution can't conduct electric current because of there is no ion. But here, electrolyte is a compound that can dissolve in water to producing aqueous solution that can conduct electric current. Because of here we have ions, but here we don't have any ions. Examples of electrolytes such as acids, both strong acids of course, and weak acids. Okay, and weak base. Why only weak base? Why? Why only weak base? Because if you remember, look, let me zoom out the screen. Look, why only weak base? We have weak base as an electrolyte. Look, okay. Strong base, it's ionic compound, but now we are living in a molecular compound section. So strong base locates in there, but here we have a weak base. Actually, look, ionic compounds, they are fully polar and fully electrolyte. But why we write them in here? Why we separate them here? Because of they have a different type of bond of assembly. Here we have covalent bond. Look, covalent bond. But here we have ionic bond. That's why we separate them from each other. Okay, ionic bond, they are fully polar and fully electrolytes, okay, such as strong bases and salts. They are fully electrolyte and fully polar. But why we separate them from into there? Because of they have ionic bond. But in here they have covalent bond. Okay, here they have covalent bond. That's why for molecular compound we have polar and non-polar. Polar we have electrolyte and non-electrolyte. And non-electrolyte they can't conduct electricity because of they don't have ability to producing ions. But here aqueous solution of electrolytes, when they dissolve in water, they can conduct electric current because of they have ability to producing ions. So that's the difference. Non-electrolytes, they can't produce ions. They can't produce ions. But here, yeah, they can produce ions. Okay. Well, now I'm going to mention some reactions for non-electrolyte and electrolytes in order to understand better. Okay. Well, I have to return back into its original size, which is 100, I think. Come on, 100, come on. Okay. Well, actually, I agree with 75, 97, 99. No, this is zoom out. 99 is good. Well, okay. Now, I want to write some reactions to see why they cannot conduct electricity. For example, we have sugar, okay, C6H12O6. When we put sugar into water, okay, as a first we knew that sugar is solid, right? When we put into water, it will be C6H12O6, okay, as a dissolvent. So it become only a dissolved molecule, okay? The bond between carbon and hydrogen and oxygen won't be break apart. That's why there will be no ion. So what will happen to non-electrolytes when we put them in water? Okay, they become a dissolved molecule. Well, what's your idea about the ions? No, they can't produce ions because of the bond between their atoms, okay, so strong, so it won't be break apart. But for the electrolytes such as HCl, when we put HCl into water, look, HCl provides H, which attacks water molecule to producing H3O, positively charged, and Cl negative. So here we have ions. That's why it can conduct electric current. That was the classification of the compounds so quickly. Okay? Hopefully you understand it very well. Please, please, please watch this video more than one time. It's very important. They are basic information. You know, after passing a period of time, you're gonna be so familiar with those informations. So don't worry and don't be upset, please. Okay? Well, let's return back to my lovely pamphlet. Okay, here we're going to start by section 1. Section 1 is about compounds in their aqueous solutions. Well, look, by the way, as I told you, you have to memorize, you have to remember the ions. What are the polyatomic ions, monoatomic ions? Okay, so I'm going to skip those pages. Look, it's very important. You have to remember, okay? It's very important. We don't have enough time to explain the acetate CH3COO negative. Okay. What's the importance of that? Nothing. You have to memorize. So it doesn't need to explain. Okay? Well, list of strong acids and bases. Again, it's one of the most important pages. So you have to memorize all of them. Look, let me tell you something. List of strong acids and strong bases. This is mandatory for chapter 2, chapter 3, chapter 6. Okay? These are very, very important. You're going to face a big problem if you forget about them, so they will forget about you again. That's why, please, take care about them. They will take care about you also. Strong acids and strong bases. Well, strong acids such as hydrochloric acid, hydrobromic acid, hydroiodic, and sulfuric acid, chloric acid, perchloric acid, nitric acid, etc. Weak acids such as hydrofluoric acid, hydrocyanic acid, okay, and hydrosulfuric acid, formic acid, this is formic acid, and acetic acid, it has another name which is ethanoic acid, okay, and sulfurous, phosphorus, and phosphoric also. For now, only memorize ammonia, and later we will learn about aniline and methylamine. Strong bases: sodium hydroxide, rubidium hydroxide, lithium hydroxide, potassium hydroxide, till the end. Barium hydroxide, calcium hydroxide. So you have to memorize each of them carefully. Well, actually, as I say, this is not all of them because we have them still, but you know, please memorize them. And now, if you remember, hopefully, for the about the classifications, we have ionic, right? And we have molecular compound. For the ionic, we have strong bases and salts. For the molecular compounds, if you remember, molecular compounds, we have nonpolar and polar. Okay, remember? Okay, it's very important, very good. Molecular compounds, we have polar and nonpolar. Well, let's continue. How continue? Okay, good. Molecular compounds, we have polar and nonpolar, right? For polar, we have electrolyte and non-electrolyte. Nonpolar, we have what? Sugar, and for nonpolar, sorry, compounds that can dissolve in water, such as benzene, oil, gasoline. Okay, but for polar, we have electrolyte and non-electrolyte. Very good. Now let's continue. Look, for polar, we have polar non-electrolyte and polar electrolyte. Polar non-electrolytes such as sugars and alcohols. polar electrolytes such as strong acid, and weak base. What about strong base? Strong base, do you remember? We have right here as an ionic compound. So don't confuse again, please. Well, the most important point, okay, here we go again. Look, if you remember, for polar non-electrolyte, I said no ion. No ion. Where's, okay, no ion. But here, yes, there will be ions. Okay, it has ion. Okay. Here we have no ion, but here, yes, it has ion. That means it cannot produce ion, but it can produce ion. So in here doesn't ionize. Does not ionize, okay? Does not ionize, but here, yes, ionize. Ionize in water. So please, this is our point. Polar non-electrolyte, they don't ionize when we put them in water. That's why we're gonna get no ion. But here, yes, they ionize when we put them in water. That's why they will produce ions. So for the polar electrolyte, yes, they ionize in water. Don't forget, it's very important. Polar non-electrolyte, they don't ionize, but here, yes, they ionize in water. That means strong acids, weak acids, and weak base, when we put them in water, they ionize. But here, what will happen? Okay, they become a dissolved molecule. Scarce, okay. They become a dissolved molecule. Okay, and now let's answer this question. Look. Okay. A molecular compound that can ionize. A molecular compound that can ionize. Okay. First of all, it must be molecular. Okay. Let's go through this filter. How many molecular compounds do you have in this multiple choice question? Okay. Sucrose, yeah, it's molecular compound. Ethanol is alcohol. Yeah, it's molecular compound. HF, it's acid. Yes, of course, it's molecular compound. NaCl, no, it's ionic. It's ionic compound. So, according to the first filter, okay, it kicked out. Okay, we just take it. We have to take out NaCl in the question because of its ionic compound. We're going to take care about only molecular compounds. And now let's go through the second filter, which is can ionize. Can ionize. Which of the following can ionize? Ionize, I remember, mister, you told me. Well, first of all, it must be polar. Okay. They are polar, and it must be electrolyte because of during the ionization, it yields ion. Okay. So we have to look for electrolyte. It's non-electrolyte. It's not. It's non-electrolyte. There's also non-electrolyte. No, it's not. Also, HF, yeah, it's weak base. It's weak acid, sorry. Okay? It's weak acid. So, because of its weak acid, yeah, it can ionize in water when we put them in water. Let's see. HF plus H2O to producing H3O plus F negative. Look. F negative, F negative. These are ions we're going to get when we put HF into water. So this is called ionization. Yeah, this is a molecular compound that can ionize. The right answer is HF. Very good. And we know that we have two major classes of compounds, which are molecular compounds and covalent compounds. Molecular compound and covalent, same name, okay? Molecular compound and ionic compound. We have two major classes. For ionic compounds, we have salt and strong bases. And now, this is our point, okay? We're going to go through a mathematical problems about the ionic compounds. Actually, I had a plan to start right here immediately, but because of I knew that the prior informations, they are much more important for you. So please read them so carefully. Okay, let's go through the salts when we put them into water. Well, first of all, salt, it's ionic compound. Its ionic compound contains ionic assembly of cation and anion. So salt, it's ionic compound, first of all. Okay, salt is ionic compound. Contains ionic assembly between cation and anion, ionic bond, okay? Good. For example, we have NaCl, your beloved salt, NaCl. Okay, it's cation and it's anion. So here we have ionic assembly between those ions, cation and anion. This is ionic bond. Okay, NaCl is ionic bond. So salt must contain cation and anion. They connected to each other through what? Ionic bond. Ionic bond. Okay, very good. So what will happen when we put ionic compound into water? Okay, take your pen into your hand and write everything that I'm going to mention from now on. Okay, let's see. Look, we have two compounds. When we have two different types of compound. When we put them into water, we will get ions. First of all, ionic compound. And here, polar, molecular, electrolyte. It's first one and the second one. For polar molecular electrolyte, we have HF. Okay, I'm going to write the title. Title is better, not the formula. Okay. For polar molecular electrolyte, we have acids, including strong and weak base. Well, for ionic compound, we have strong base and salts. Okay, let's see. I'm not finished still. Okay, it's very important. Let's see. That's the point. If we put ionic compound into water, the process will be dissociation. But if we put molecular compound, which is electrolyte, into water, the process will be ionization. Okay, so that means if we put strong acid or strong base or weak acid into water, they ionize. But if we put strong base and salt into water, they dissociate. So what is the difference between dissociation and ionization? Okay, so let's see. Dissociation, it means, look, just by writing one example, you're going to get the idea. Well, but this time I don't want to work with NaCl actually, because of I knew that NaCl criticized us. Please, why always me? So we have to change the example. For example, its brother, KCl. Okay. If we put KCl into water, first of all, you have to recognize KCl, what type of a compound. KCl, we knew that it is salt. So salt is ionic compound. It undergoes dissociation. So we have to write H2O above the arrow. Okay? So the position of water is just above the arrow. And now, the ions that already present in a molecular skeleton, in a formula skeleton of the compound, they become apart from each other. So they will separate from each other. Look, here we have ionic bond. Ionic bond. Water will overcome this attraction force. So it will break down ionic bond. That's why the ions that already present, look, it's very important. Ions that are already present, they separate from each other. They separate from each other. So the process of dissociation is separation of ions from each other. Okay? Look, it's very important. Take that point. Dissociation, separation of ions from each other that are already present. Another example, look, CaCl2. If we put CaCl2, okay, where's the position of water? Above the arrow, H2O. Okay, the ions that are already present, they become apart from each other. And two chloride anions. This is dissociation. Look, the ions that are already present, they separate from each other. This is dissociation. So dissociation, we can say separation of ions that are already present. Look, we got those ions, but we know previously we have them already. Calcium, calcium, two chlorides and two chlorides, we have them. So the only thing that happens, only they separate from each other. Okay. But what about the ionization? The ionization, for example, okay, first of all, you have to know ionization is a process that's specified for polar molecular electrolytes, such as strong acids, weak acids, and weak base. Okay, let's talk about weak base. This time, NH3. If we put NH3 into water, this is first difference between ionization and dissociation. Water position. During the dissociation reaction, we have to write water above the arrow. But for the ionization, the water must be added to a compound. Water must be added to a compound. So we have to write water as a reactant and plus sign between them. So it will be NH4 plus OH. Don't talk about the products where we get those, because of we have something more that makes you more understand, more makes you to get more information about how to write a product. So don't worry about the products, because of you're going to be familiar. Okay? So now we can see that first difference is water position. During the ionization, water must be right here, but during the dissociation, water must be right above the arrow. And now ions that are already present, they separate. But here, look, we got NH4. We don't have NH4 here. So the ions doesn't present already. We don't have them previously. So we can say it is forming ion. Forming ions. So the process of ionization is forming ions, but here no separation of ions. In the dissociation, water must be right above the arrow, but in the ionization must be right as a reactant. Here the ions doesn't present. This ion does not present previously, but here this ion present previously. That's why we have to say separation of ions, but this is forming ions. Another point, role of solvent. Okay, water participate of the process of forming ion. We can see that water divided between NH4 and OH. So water presents action of forming ion, but here no, we cannot see the role of water. Okay, we have only ions. So water is just a solvent, but here water works as a reactor. I don't want to go further, so for this lecture is enough, and next lecture we will start by writing reactions and make the calculation, I mean mathematical problems, then we're going some steps deeper. هیوادارم لێی تێگەیشتبوون و سوودتان لێ بینی بێت تاوانێدا تو بەخواتان دەسپێرم خواتان لەگەڵ